Hi everyone, welcome to the fourth lecture of this programming languages course. The topic for today is identifiers. Before getting into the details of today's lecture, let's review the important things. Don't in your homework or exercises. You do not have any homework yet, but you do have exercises. You already have one, and you're going to have another today. And while you are doing Scala programming, do not import any other libraries than we've allowed in your exercises. Do not use the break statement. Do not use the while and for loops because they are imperative. They break functional programming. If you don't get what I mean, you'd better go back to the previous lectures. If you don't get it yet, you have a chance to drop this course still until this Friday. Do not use mutation in the same way. So if your homework, I said homework, but it's more like what, exercises? Do not do any of the above, it will get 0 point. So you are not supposed to do these things. Identifiers. So the first part of today's lecture, we are gonna have the game. Are the following two programs equivalent? So meaning that I'm gonna show you two versions of some program. So I'm going to show you a sequence of program pairs, two programs at a time, and I'm going to ask you whether they are the same or not. Let's see. On the left, we are defining a function named f, which takes one parameter of name x, whose type is int. And this function takes one integer, produces another integer. Now you should be familiar with this syntax, right? And the function body is doing what? It adds 1 to its argument value. And when we define this function, we can call it, right? Introduction use. Introduction of a function, name the function f, and calling it. Call f with an argument value 10. So far so good. What about the right one? We are defining another function f, which takes a single parameter, but this time the parameter's name is y. And we add one to the argument value, and we call the function with the same argument value 10. Are they the same or not? What do you think? Think for a second and see. They are just the same, right? Are the following two programs equivalent? Yes, they are equivalent. They are just the same because parameter is consistently renamed. We have everything just the same except the names of the parameters, and they are renamed consistently, so two functions denote the same thing. So far so good. How about this one? So now you can see that blue things are just the same and red one is different. Here, this function is just the same function as before. And this function, the function body remains the same. We are adding 1 to y. But the thing is, the parameter name is not y as before, but it's x. Are they the same? What do you think? Yeah, they're different. They are not equivalent because not a use of the parameter anymore, because the function body on the left uses the parameter's value, the argument value, but on the right, y. What is that? We don't know. So they're just different. How about this one? Yeah, the left-hand side remains the same, and the right-hand side, the function bodies are the same, but the parameter name is different again. Then we are back to the same problem, the same question. So they are different. They are not a use of the parameter anymore. Do you see that? Okay, what's next? Then we are going to have the function f, whose body just the same, y plus 1. Okay, and the parameter name is x and z. Are they the same or not? Are they the same or not? Think. You think. What do you think? Are they the same? Yeah, they're the same. Even though we renamed the parameters differently, on the left, the parameter is called x. On the right, the parameter is called z, but they are not being used in the body. Parameter never used, so almost any name is okay. We don't care. We take an argument value, and ignore that. The functions are just the same. How about this? So as before, we take a parameter and ignore that, and the body is y plus 1. What's the value of y? Who cares? I don't know. Maybe there's some y equals 10 or something here like that. We don't know. But anyway, the question is, are the following two programs equivalent? And here, we do not use the parameter value, but here the body is just the same as this one, but the parameter name is y. So this y is not a parameter, but this y is a parameter. They are different. Right? Clear? How about this one? The parameter names are the same, and the bodies are different. But, they are not using the parameter's value. Yeah, what is y? What is z? I don't know, right? Are they the same? No, because still an undefined identifier, but a different one. So, depending on the value of y and z, they may behave differently. They may behave the same. Whether it's good or not, I don't know, but they are just different. Do you see that? What we are trying to do is to understand the meaning of names. Identifiers, those y, x, they are z, they are identifiers. And what are they? What do we know about them? How about this? It looks a little bit more complex. Let's see. This time, the function f has a sequence of expressions in the body. The first expression is identifier declaration, meaning local identifier. This y is local. Local meaning that this name y is available from here to here. This name y is available from here to here. Right? Then I say y's value is 10. And the result of this function f is going to be x plus y. X is going to be the parameter. And we are going to call f with 0. How about this one? Y's value is 10. Oh, yeah, just the same. And the result of this function body is going to be z plus y, the same y. What about z? Z is the parameter. And we are calling those two functions with the same value. Do you see the structure? You see those definitions, right? Are they the same or not? What do you think? Do you see that? Are they same or not? They are just the same, right? Even though they look slightly more complex because the function body is not a single expression but two expressions enclosed by curly braces, right? Even though they have local identifier declarations, even though they have different names for parameters, they are just the same because, again, parameter is consistently renamed. That is the important thing. Let's see more. Now this time, function f they have the same parameter name x. Previously, they had different parameter name x and z. This time, they have the same parameter name x. And in the body, they both have two expressions in a row in the body. Again, the first expression is a local identifier declaration, and the second expression is an addition. And in the definition of function f on the left, the name of the local identifier is y. On the right, the name of the local identifier is z. Their values are just the same, 10. In the body, we are adding the parameters, argument value, and again, the value of the local identifier. In the body on the right, we are adding the parameters value, x value, and again, the value of the local identifier z. And we are calling those two functions with the same argument value 0. Are they the same or not? This 0 is going to be passed to here. This 0 is going to be passed to here. So x's value are going to be both 0. And y's value is 10, z's value is 10, and we are adding them. So are they the same or not? Same, because local identifier is consistently renamed. Just like parameters that we saw before, just like we said that whether parameters were renamed consistently or not, we don't like to know whether local identifiers are renamed consistently or not. Local, right? Local, meaning that they are available only from here to there. It is available only from here to there. So outside of the function body, if I say x, I don't know what it is because the function parameter is available from here to there. When I say z here or x here, we don't know what they are because the function parameter x and the local identifier z, they are available only inside the function body, right? Again, the value of the function parameter is available only at the function call site. When we define this function f, the value of x is not available. We don't know. We don't know what the value of x is here because it's not yet being called. When it's being called like here, when it is invoked, when the function is being called with the actual argument value, 0 is going to be bound to the parameter x, and x's value from here is going to be x, is going to be 0. And z's value is going to be 10 right after this local identifier declaration. Right after that, we know that x is 0, z is 10, so we know the value of this. So, let's see. They look similar but different. Now you can see that what we are interested are names, right? Identifier names, either parameter names or local identifier names so far. So we need to see whether parameter names are same or treated in the same way. Luckily, parameter names are just the same. But look at that. Local identifier, they are different. Okay, here we are adding, again, the value of the parameter and the value of the local identifier. Here, the name of the parameter and the name of the local identifier are just the same. Then when we say x plus x, what are they? Is this x this one or that one? Let's say this is number 1x, this is number 2x. Is this x number 1x or number 2x? Is this x number 1x or number 2x? Because I color them blue and red and blue and red, do you want them to represent the other? Maybe not, right? Maybe not. Because in our editor, you do not have colors. Let's see one more time. Here, okay, parameter name x is going to be available right here from the beginning of the function body. And then we are defining another name x here. Then, which one is going to be available here? Do you want to allow this code at all or not? When we allow this one, do you want this X to denote this or that? Do you want that blue X and red X denote the same thing or not? There could be many questions like that, right? Yeah. Different languages have different semantics. You do not need to worry that your answer may be wrong because there could be no correct or wrong answers until we say which language we are talking about. So, when I say name X here or name Y here, what do we mean by that? And what are their scope? That's what we'd like to know. When we have the same name in the same scope, we are going to talk about scope later more formally, but before that, let me just tell you high-level description of this problem. When we use X, when we name X, we'd like to know what that denotes. When we say X here, we'd like to know what it is. In some languages, when we have two occurrences, two introduction of the same name, some languages reject that. Hey, there are many other characters. Why do you want to use X for two different things? That's one reasonable opinion, right? So as soon as we have X as the primary name in the function body, because X is available here, when we redeclare X here, then some language, some compiler will say, hey, error. You are not supposed to define X because it's already defined here. That's one option. What else? Oh, you're defining X, but you know what? This one came first, so I'm going to ignore you. And these two X's are going to denote this. That's another option, right? Outermost wins over innermost, right? So this is inner, meaning that it's closer to this use site, but we are saying that the outer one wins over the inner one. That's one possible option. Yeah, there's not that many languages that has this semantics. Actually, I don't know which one has that. Let's see the third one. Yeah, these are use sites, and this one is closer to the use site. This one is inner meaning that let's talk about the scope. Yeah, right? X plus X is the innermost, and then we have this X local X declaration, and we have this function declaration. They are all enclosed by the other. So this is the outer one, and this is the inner one. And when we use these names X, we are going to say, yeah, the closer one, the inner one wins over the outer one. So this one is shadowed. Oops, good. Or hidden. Because this is important, I'm going to repeat this in Korean and move on. 간만에 한국말로 하네요. 이 이름이 얼마나 어디까지 살아있는가? 그게 스코프예요. 나중에 브레이크 후에 다시 한번 제대로 설명해 드리겠지만 지금 그냥 간단하게 말씀드리면 X라고 부를 때 갸가 뭐 모르겠어. 그죠? 보통 가장 많이 쓰이는 경우는 사용하는 곳이랑 제일 가까운 애가 이겨요. 그래서 바깥에 이미 있었던 올드한 애들은 가려져요. hidden 가려지거나 shadowed 그림자처럼 가려져요. We are going to get back to this scoping thing in a minute. I mean, after the first break. So here, even though I said multiple things, because this y's value is 10 and this x is going to be the parameter, but these two x's denote the same thing. Yeah, those two programs are different. Local identifier now hides the parameter. Right? Do you see that? What about this one? Local identifier remains just the same, but this time parameter name is y. Again, we are in the same stage, right? Same status. Local identifier now hides the parameter. They are different. Okay, so now what we have been doing, so-called the game, is to tell you about identifiers. When we talk about identifiers, I'm gonna say three things: binding occurrences, bound occurrences, or free identifiers. Before the break, I'm going to explain these three very important concepts, and then you're going to have a break. When you come back from the break, I'm going to explain this one more time and then move on. And we're going to define a new language today. Okay, let's talk about these important concepts in 3 minutes. An identifier for the parameter of a function or the name of a local identifier is a binding occurrence. So here, those red things are binding occurrences. Function parameters and local identifier declarations, they are binding occurrences, meaning that introduction of names. We are introducing new names here, X and Y. They are available in the function body. We are introducing names A and C, which are available in this local scope. Binding, we are introducing new names. Bound, meaning that use of a function parameter or a local identifier. That's bound, right? Do you see this active and passive tense? 능동이랑 수동이 보여요? Binding meaning that we are actively introducing name. Bound, meaning that the names were already introduced and they are being used. Do you see the difference? Those parameter names and local identifier declarations, they are binding, introducing new names. And the use sites of them, X and Y in the function body, A and C in the subsequent expressions that use those names, they are called bound occurrences. And finally, if an identifier or use of an identifier that is not a function parameter or a local identifier is a free identifier. Free, 자유죠, 자유. Free, meaning that you do not have an owner. You do not have any introduction point. No one introduced you. There's no binding occurrence for you. Oh, that's too bad. You are free in the sense you are an orphan, in the sense you are on error. Really? Yeah, look at this. In this function f, we have two parameters x and y. And we are going to get the value of x and y from the call site, right? And what's the value of z? If it's the entire function, the entire program, we do not have the value of z, which means that z is a free identifier. It's an error because we don't know the value of z. What about g? Yeah, look at this function. In the function body, we have local identifier a and c. They are bound. A is a bound occurrence whose binding occurrence is here. C is a bound occurrence whose binding occurrence is here. Then B is free. So when you are given some code, you should be able to identify binding occurrences. You should be able to identify bound occurrences, and you should be able to identify free identifiers. Okay? Let's take a quick break. Geese are everywhere in the campus, right? Now they are climbing down from some hill. They like to be lined up.